Now I would like you to explore a little bit with your graphing calculator, and I'm going to ask you to graph on your calculator f of x equals x squared plus 3x minus 5. So immediately you should be able to picture what that's going to look like in your head. You should know what shape that is. And the absolute value of f of x, which would be the absolute value of x squared plus 3x minus 5. So if we, you're going to go ahead and in just a minute pause the video, but you're going to type in these two functions. And what I often will do if I'm comparing two functions on my graphing calculator, if you come over here to the left side of the y2 and hit enter, it will change that to a thick line. So now if I hit zoom 6, I'll be able to compare those two and then describe what you see. So I'm going to ask you to pause the video, set your calculator up and do this, and then describe what you see. So you should have gotten this graph, and if you notice, there are certain parts of it that that look the same. The parts that were above the y-axis, those are the same. It traced over the same part. But the part that was below the y-axis, notice what happened to it. It got reflected over, I'm sorry, I said the y-axis, but I meant the x-axis. The part that was below the x-axis was reflected above it. And if you think about, does that make sense? Well, we're taking absolute value. Think about what absolute value does. It takes negative values and makes them positive. So all of the negative f of x values that were below the x-axis were reflected and became positive. So if we were to put words to this, we could say it reflects, it reflects the negative portion of f of x across the x-axis. So that's helpful to know, because now you could make predictions about graphs even without graphing them on your graphing calculator. Now we're going to see what happens if you compare the same function f of x, so the same parabola, but this time we're comparing it, instead of the absolute value of f of x, we're doing f of the absolute value of x. So that's a little different. So what that means is I'm taking the absolute value, so everywhere where you see, I'm taking absolute value of x and plugging it in everywhere you see an x. So I end up with the absolute value of x squared plus 3 times the absolute value of x minus 5. So go ahead and set up your calculator. So delete what you had in y2, plug this in instead, still leave it to a thicker line, and pause the video, check it out, see what you see, and see if you can make a prediction, if you can kind of determine what's happening. So there's my regular parabola. What do you think? Notice that the positive side, the part that's to the right of the y-axis, that didn't change. But this seems to have kind of disappeared. However, we have this instead, so it looks like it's a reflection of the positive y values, positive x values, I should say. It's a reflection of the positive x values across the y-axis. So it appears that the positive values of x are reflected across the y-axis. So again, now we can make some predictions. So knowing what a particular function looks like, now we can make predictions about taking the absolute value of that, of x, and plugging it into the function. Here's a picture of the key concept from your textbook. So again, it shows if you take the absolute value of f of x, then you can see what happens. The part that was below the x-axis was reflected above the x-axis. And if you are evaluating f of the absolute value of x, then it takes this positive portion, so it was this part here, took this part here and reflected it across the y-axis, so then that part ended up creating this section over here. So let's see if we can do this one now. Use the graph of f of x equals x squared minus 4x plus 3 to graph the function g of x equals absolute value of f of x. So on this one, I'm taking the absolute value of the whole function. So you have to determine what kind of reflection are we expecting here. So this is the one that's going to reflect across x-axis. Now remember, it's only the negative portion. So this part is going to remain the same. So we'll still have that. This portion that was below the axes, now I want to get a fairly accurate sketch. So this point right here is going to reflect to this here, and we end up with a graph that looks like this. Now let's try this one. Last example here. Use the graph of f of x equals x squared minus 4x plus 3 to graph the function h of x equals f of the absolute value of x. So now this is the one where I am reflecting it across the y-axis, but remember, it's the portion that this portion here is going to get reflected. So that means this point is going to reflect to here. Let's have this point, so 4, 3 is going to reflect to negative 4, 3. And I'm just doing these so I can get a better sketch. I probably will mess it all up anyway, but kind of hard to draw on here. Okay, that wasn't too bad. So that portion gets reflected across the y-axis, and so we end up with this graph that I have in red.